By now you've read the title and you've seen the intro, so you know I'm going to build some kind of robotic or animatronic hand. We've all seen a lot of Arduino robotic hand projects. Usually the creator builds some kind of a glove that can detect the amount that each of your fingers bends, and then it translates that into some information for the robot hand to be able to track it. I actually think that's a really cool project, but I want to do something a little bit different for my version. So instead of building this glove thing that controls the hand, I'm going to use a leap motion. If you're not familiar, this is a little sensor that you plug in USB to your computer, and it's able to very accurately detect movements in your hands and fingers. You also might be wondering why I put the word animatronic instead of robotic in the title, and that's because rather than building a hand that I can only directly control, I actually want to be able to record motions and save them, and then be able to play those back later. You know, like an animatronic that you might buy for Halloween. The design of this project is actually going to be very similar to my Kinect turret. There's going to be an app on the PC that is interfacing with the leap motion to gather data about my hand. And then over serial, it's going to send that information to an Arduino, which is connected to 5 servo motors, 1 for each finger. And it's going to use the leap motion data to set those servos. And on top of that, the Arduino is going to be able to record motions and save them to a file for playback later. Now, where the Kinect was super easy to work with, well documented, and gave me great data on where all the body parts of a person being tracked were, the leap motion, at least the current version of the SDK, is a little bit lacking. I wasn't able to find any current API just to tell me what I can do with the code at all. There were old versions, and fortunately most of the stuff I found in the old versions of the documentation did work. But this thing is kind of weird. It sort of sets up its own coordinate system in Unity rather than using what's already there. And so once I started figuring out how to work with it, the challenge really became, how do I tell how far closed or open a finger is? You get a lot of data. It tells you about the position and orientation of every bone in each finger, plus information about the palm and a few other things. So I started trying to rummage through all that to figure out the rotation of each finger and figure out where it would be closed. But you know, on the mechanical side, I'm only going to have 1 degree of freedom for each finger, a single servo that can pull it open or closed. While it would be cool to build a hand that individually controls each joint, I don't really need that. So I just ended up going for the simplest solution I could think of. I know where the fingertip is for each finger in 3D space, and I know where the palm is. So I just find the distance between the fingertip and the palm. And you know, as the finger closes, that distance tends to shrink. It may not be a perfectly linear and precise way of doing things, but I think it gets the job done. I ended up using a Node MCU ESP8266 for this project, which is what I also use for my smart space heater controller. This development board is kind of overkill for this project because all I really need is 5 PWM signals. But this thing gives you Wi-Fi connectivity and a bunch of other stuff. But what it does have that made me decide to use it is a built-in file system. So I don't have to also hook up an SD card reader in order to save and read my recorded animation files. And you can get these for like, I don't know, $6 or $7, I think. So as far as microcontrollers go, this thing is kind of the best bang for your buck that I've found. The only downside is that it's a little bit bulky. So if you're trying to build a small project, you know, it might be hard to fit this in. Also, I did have one burn up spontaneously on me while I was working on this project. So I don't know if there's a known quality control issue with these, but I'm hoping that was just a one-time fluke. Unfortunately, I didn't get it on camera, but I will show you what it looked like.
Okay, let's see how that's working. Oh no!
I tried a few different designs for the fingers before settling on one using nylon tubing. And the first thing I did was put a wooden dowel through the tubing and then heat it up with a heat gun so that after I took it back out, the tubing would be straight instead of its natural coiled shape. After that, it was just a matter of cutting out the right length for each finger and then cutting notches for the joints of the fingers so that they would be able to bend. After that, I cut a hand out of some thick cardboard. And to give it a little more rigidity, I actually cut a second piece and glued them together. And here's a fun crafting tip. Cardboard actually holds screws really well. I tied some fishing line to the tip of the finger and then ran that down the tube. This is what the servo will attach to so it can pull the finger closed. It took some fine tuning to balance the springiness of the tubing with the amount of force that the servos could handle. Next, I decided on positions for each of the servos and then carved out holes to mount them on the hand. Once they were mounted, I also cut out a channel on the back to run all the wires. And then finally, I had to line up all the servo attachments and then tie the strings from the fingers to their corresponding servo, which can be a little bit tricky when everything is under tension. And that's basically the whole build. So after that, it was time to write some code. Oh, and also this nylon string for crafting seemed to work a little bit better than actual fishing line. It was a little less stretchy and the knots didn't slip as easily. I'm once again not going to talk about the particulars of the code in this video. I don't know if there's much entertainment value for that. Feel free to let me know down in the comments if you would like to see more of the code in the videos. But the code will be on GitHub, and I'm also planning to put up a more detailed written tutorial, and both of those things will be linked down in the description. And also don't hesitate to look up All Parts Combined on Reddit, where you can DM me any questions you might have. I will just mention that the code for this project just looks like a mess of switch statements. I mean, seriously, I got switch statement, switch statement, switch statement, switch, switch. It's kind of ridiculous, you know? And one of these days I'm going to actually start organizing my Arduino code into header files and stuff like that, but today's not that day. This is it all put together. So I've got the microcontroller on a little breadboard with each of the finger servos plugged in. Each one is labeled so that I don't get mixed up, and a little rechargeable battery here to power the servos. And the wires actually run through a little channel I made on the back. And of course, each servo controls the position of a finger. The thread for each finger runs through the bottom of the tube, through the first two joints, and then it comes out the top joint so that it can tie to the tip of the finger. And that gives a good leverage to pull into a curled position. Of course, if you want to try to make this look more like a hand than a bunch of cardboard and tubes, you can throw a glove on it. And just like that, you have a realistic animatronic hand. Let's take a look. Just ignore the way the palm sort of wiggles all around. This is my Unity app this time around. Let me go ahead and maximize the game window. Alright, so this is the main application. And now the first thing you would want to do if you're using this is jump over to the calibration mode. Alright, so I need to start tracking my right hand. Open it completely and press spacebar. Fist and spacebar. Alright, and that's it. Calibration is done. Now, if I'm in here, you see that I'm printing out the percentage closed for each of my fingers. All the way closed, all the way open, and it works for each individual finger. You get the idea. Now, I'm currently in off mode. During off mode, the robot hand does not respond to anything, and it just sits in a neutral open position. Now if I flip over to live mode, the robot hand will start responding. And if I flip over to playback mode, then I'll be able to play through the pre-recorded animations for the currently selected file. I'm going to jump back to live, and I'm going to go ahead and record on file 4 a new animation. To start recording, I can either click the big red button in the bottom right or just press the R key on the keyboard. Press R again to stop, and then if I play back, and yeah, that is how it functions. Pretty cool, right? Now you might have seen this book sitting in the background, The Ultimate Guide to Do-It-Yourself Animatronics by Steve Kosey. Hopefully that's how that's pronounced. Anyway, this is a really helpful resource if you're into building projects that involve making stuff move. This book is actually where I pulled the design from for the hand using the nylon tubing. There's a complete walkthrough of that, as well as a whole bunch of other animatronic parts you may want to build, plus just tons of general information about how to do electromechanical projects. And I'll make sure to put a link to this in the description as well. So yeah, that's pretty much it in the current iteration. There are some improvements I would like to make. I think it would be cool to add a push button somewhere so that I could cycle through the different animations without having to connect the whole thing up to the PC. I also think it would be really cool if I could add wrist control to it in addition to the finger movement so that I could get a lot more of a lifelike motion. And I also really want to revisit this wooden design for the fingers. This was just sort of crudely cut. I don't actually have the proper tools or materials to be able to build this right now, but watch out because there will almost certainly be a future video where I try to rebuild the whole hand out of wood. I just think that'll be really cool looking. Plus, the nylon tubing is a little bit slow to return to its open position, whereas wood with a spring attached is much more responsive. You can find most of the parts I used in the description below in case you want to try to recreate this yourself. If you feel like giving me a hand, I would appreciate it if you liked this video. And if you want to see more cool stuff, subscribe to the channel. See you next time.